Welcome to FM Education Academy, a place where quality content is provided to all students. It is on your request that we provide educational videos daily. So please, if you find this video helpful, then like this video, share this video with your friends, and also please subscribe to this channel and turn the bell notification on. In today's video lecture, we will be discussing question number 2, third bit from the chapter 1, Functions, TS and AP, Telugu Academy textbook, exercise 1A. In the previous two lectures, we had done second question, first bit and second bit. In today's video lecture, we will be doing third bit, fourth bit, fifth bit and sixth bit, inshallah. So let's start. It's asking us which of the following are injections or surjections or bijections. Third bit is f is mapping from 0, infinity to r defined by f of x is equals to log x to the base e. So first of all, as we know that we will find out if a function is injection, then we will find out if a function is surjection, and then we will find out if a function is bijection. So to find if a function is a surjection or not, we know that we have to assume let f of x1 is equals to f of x2. If we say that f of x1 is equals to f of x2, what is f of x here? Log x to the base e. So f of x1 means in place of this x write x1. So log x1 to the base e is equals to f of x2 means in place of this x write log x2 to the base e. Now log will get cancelled on both sides, so we have x1 is equals to x2. So when we had assumed f of x1 is equals to f of x2, we got x1 is equals to x2. Remember, the condition for injection is that only we have to let f of x1 is equals to f of x2, and if we get x1 equal to x2, then we can say that it is an injection. Okay, it is an injection or 1.1 function. If x1 will not be equal to x2, then it will not be an injection. Okay. Now we know that since x1 is equals to x2, f is an injection. Now we have to find out if s is an surjection or not. How to find out if f is surjection or not? You have to let y is equals to f of x, get the value of x, and see whether you are getting y is equals to f of x or not. If you are getting y is equals to f of x, then you can say that a function is a surjection. So we'll assume let y is equals to f of x over here. We know that f of x here is log x to the base e. And we also know that if log n to the base a is x, then a power x is equals to n. We'll use that formula. If log n to the base a is equals to x, then we have a formula a power x is equals to n. Okay, so compare this with this formula. Log x to the base e is log n to the base a, and y is x. Then what do we have? A power x is equals to n. So compare what is a here. A is e. So e, what is x here if you compare? X here is y. Okay, we are comparing this with this. X here is y. So e power y is equals to n. What is n if you compare here? Log n to the base e means log x to the base e. X is equals to y. So what is a power x is equals to n? What is n here? N is x. Compare. X is n, a is e, and y is x. So here we have e power y is equals to n. What is n here? N is x. So we got e power y is equals to x, or we can say that x is equals to e power y. What is this e power y? E power y is nothing but it is a function of y. So we got to know that x is equals to f of y. Now what we'll do is we'll substitute this value of x in this f of x. So what are we going to do? We are going to substitute the value of x in this function. Log x to the base e. What is x? We got e power y. So log e power y. In place of this x, substitute the value of x, that is e power y. So e power y I am writing in place of x to the base e. It is of the form of log x power n to the base a. What is log x power n to the base a? Log x power n to the base a is n log x. So compare what is x e, what is n y, what is a e. So n log x means n here is y if you compare. So y log x to the base e. X here is e to the base e. So this is again the form of log n to the base n. What is log n to the base n? Y. Sorry, log n to the base n is 1. So we have y into 1. Why are we writing y into 1? Because we know log n to the base n is 1. I'll write that formula. Log n to the base n is 1. Okay. So LHS was f of x and RHS we got is y. That is, we got to know that f of x is equals to y. So we had assumed y is equals to f of x. We got x in terms of f of y, and also we got f of x is equals to y. Therefore, we can say that f is a surjection. And we know that if f becomes surjection and injection both, then it will be a bijection. So we can say therefore f is also a bijection. Moving on to fourth bit. Okay, so here it's given f is mapping from 0 comma infinity to 0 comma infinity, and f of x is equals to x square. Now we know that whenever we have to find out f of x is an injection, what we have to do, we have to say let f of x1 is equals to f of x2. So here also we'll say let f of x1 is equals to f of x2. If f of x1 is equals to f of x2, then we can say x1 square. Here f of x is x square. So what is f of x1? x1 square. And what is f of x2? x2 square. Now since they are positive values, 0 comma infinity, we know if we do 2 square it will be 4, 3 square it will be 9. That is, we'll get positive values. So even if we send square, that side becomes positive only, right? So here now square will get cancelled, because we know that if bases are same, powers are also equal. So here we got to know that x1 is equals to x2. So even though we had a function of x square, since they were positive values, therefore even if square is there, they didn't become negative, and we got x1 is equals to x2. Okay, suppose if it were not positive values, it is 0 to infinity means positive values, then x1 will not be equal to x2, but here they are 0 comma infinity, that is all possible values. So since we have got x1 is equals to x2, we can say f is an injection. Now we will find out if f is a surjection or not. To find f is a surjection, we will assume f of x is equals to y. So here what is f of x? F of x is x square. So x square is equals to y, and here we know that what is the value of y? Y value is from 0 to infinity. So let y belong to 0 comma infinity. Also we will write. Now x value we want, right? So x is equals to square, if it goes that side becomes square root of y. Now we know that here y are all positive values because y belongs to 0 comma infinity. So we'll get positive values only. That is, we got x is a function of f of y. Now what to do? In place of this x square, okay, that is this x value, what we have to do, this x value we have to substitute in this function. So we have to find out what is f of x. That is nothing but f of x is nothing but a function of root y. So function of root y means what it is? In place of this x square, function of root y means x square. So in place of x, substitute y. So root y whole square. Square and root will get cancelled. We got y. That is, LHS was f of x and RHS is y. So we got f of x is equals to y. So here we can say that it is a surjection. So therefore f is a surjection. Now we got to know that f is an injection as well as f is a surjection. Therefore f will also be a bijection. Now fifth bit is f is mapping from R 0 comma infinity, defined by f of x is equals to x square. Real numbers are there, and real numbers we have 0 comma infinity. Okay, so now what we'll do is, here we have, where are they? They are mapping from real numbers. See here, real numbers means negative values will also come here. Okay, in the earlier sum, both were 0 comma infinity, that is positive values only, but here we are having real numbers. Okay, so that also we have to consider. So first of all, let us find out if it is an injection or not. How to find out if it is an injection? Let f of x1 is equals to f of x2. Here f of x is given as x square, so x1 square is equals to x2 square. But here, can we cancel these two powers? No. Why? Because we need to find out the value of this x1. To find out the value of this x1, we know that they are ranging from real numbers. There is negative values will also come here. So square, if it goes that side, becomes square root of x2 square. Okay, that is nothing but square and root will get cancelled, but we will have plus or minus, and also we know that it will be plus x2 or minus x2. But in the condition of proving it is an injection or not, we know that we should have x1 is equals to x2, but here we are getting x1 is equals to plus and minus x2. We are also getting minus x2. We should not get minus x2 for proving it is an injection. So since we are not getting x1 equal to plus x2, therefore we will say f is not an injection. Now let us prove if it is a surjection or not. So for that, it's given that y belongs to 0, infinity only. These values are there in y, but the function was from real numbers. Means when I consider x1 value, to find out x1 value, I should consider this real numbers, but y actually belongs to 0, infinity only. So let y belongs to 0, infinity, okay, and we know that y is equals to f of x. Here we are assuming. So what is f of x here? X square. Now to find out the value of x, what we'll do? X square is equals to y, or x is equals to square root of y. Now these will be positive values only, plus root y only. Why it will be plus root y? Because here it is given that y belongs to 0, infinity. Okay. So we got to know that f of x, now we'll find out f of x value because we got the value of x. How to find out f of x? We know that we have to find out a function in root y. How to find out a function in root y? In place of this x, we have to write this value, x square. So f of x, actually function of x means I have to find out what is the value of x square. In place of x, substitute root y. So root y square means square and root will get cancelled. That is, I got to know that f of x is equals to y. I had assumed let y is equals to f of x, and also I got the value of x, and now I got f of x is equals to y, and it is positive. So I can say that since I got f of x equals to y, it is a surjection. And since but will it be a bijection? No, since we got that it is not an injection but it is a surjection, so it will not be a bijection. Why it will not be a bijection? It is not an injection but it is a surjection, so it is not a bijection. Okay. Now this bit, if you observe, here it is saying f is mapping from r to r. That is, both are real numbers here. That is, y also belongs to real numbers. That is, y can also be negative numbers, and x values will also be real numbers only. Okay, both are real numbers here. So first, to find out if it is an injection or not, we know let f of x1 is equals to f of x2. So f of x1 means here it is given x square, means x1 square is equals to x2 square, and we know that since it is real number here, x value is also real number, so it will be x1 is equals to square root of x2 square. Square and root will get cancelled, but we will have plus or minus. Since we are having x1 is not equal to minus x2, we are having x1 is equals to plus or minus x2. x1 is equals to x2 we didn't get, so we can say that f is not an injection. Okay, why are we having plus and minus both? Because here we are having x belongs to real numbers. Now to find out if it is a surjection or not, we know that y is belonging here to real numbers, not to 0, infinity, because we don't have 0, infinity here, we don't have 0, infinity here, we are having y belongs to real numbers here. So what we'll do, let y is equals to f of x, and what is f of x here? X square. So we'll get x is there is equals to y, or I can also write, so x is equals to square, if it goes outside becomes square root, but here also I'll get plus or minus y values. Why I'll get plus or minus y values? Because clearly it is telling that y is belonging to real number here. That is why I'm getting plus y or minus y. And now let us see whether we are getting a pre-image or not for negative values. We know that if x is plus 1, if y is plus 1 here, root plus 1 is plus 1 only. And if y is minus 1 here, okay, if minus 1 here, then root minus 1 cannot be found out, because we know root of negative numbers cannot be defined. So here we are not getting an image of x in y here. Pre-image we are not getting. So we will say that pre-image does not exist for negative values. Since pre-image is not existing for negative values, here we didn't get f of x is equals to y. We had assumed y is equals to f of x. We got the value of x is equals to plus or minus root y. But when we substitute this value of x is equals to plus or minus root y in this, we'll get a negative answer. And we know root of negative values cannot be defined. Since root of negative values cannot be defined, we'll not get an answer only. It means that pre-image does not exist for negative values, means it is not a surjection. So we can say f is not a surjection. And since f is not a surjection, f is not an injection, then f will also not be a bijection. Okay, this completes our second question, third bit, fourth bit and fifth bit, third, fourth, fifth and sixth bit. In the next video lecture, we'll be doing third question of exercise 1A from second section. If you have found this video helpful, then please like this video, share this video with your friends, and also please subscribe to this channel because we upload video lectures daily for you all. Thank you.